So next we have my old friend, Rich, and Rich has been in this area before this term was cool. So it's going to be very exciting to hear a new perspective from.
Thanks so much, Abhishek. I first met Abhishek and Ramesh in Europe in 2022 at the first decentralized AI workshop at a big AI conference. So yeah, we've met many more times during in different parts of the world. And it's really amazing to see that this platform, this shared platform that we always talked about is coming together. Okay, so I'm going to talk a little bit about three different things in this short presentation. So the first is going to be why decentralized AI, and it's a different reason that I haven't heard from anyone else today. Then I'm going to talk about, the platform for the Internet of Agents that we've been building for 2 or 3 years and the different components of that. And finally, I'm going to talk about a product that we just launched yesterday on top of this platform of the Internet of Agents. Okay, so why decentralized AI? So I came into the space for ethical reasons. I used to work in centralized AI as a machine learning engineer, and I saw things around data and surveillance that I didn't like. And I quit my job to explore different ways of doing AI. But even though I came in for ethical reasons, I think you'll probably only get, a small percentage of people that come in for this reason. I think to get the mainstream of AI to come in, we just have to show that decentralized AI is better and more performant than centralized AI. So you might recognize some of the papers here. More agents is all you need, mixture of agents. There's one called Internet of Agents as well. And what all of these papers show is that as you increase the diversity of things like the models, the architectures used between different agents, the local knowledge and local tools available to each agent, you improve the performance of the overall multi-agent system. And I think what we're going to start to see in probably next year are multi-agent scaling laws, which is what you see on the right-hand side. This is actually different to the other scaling laws graph. The other one was scaling inference time compute for a single agent. I think what we need to move towards are scaling laws for multi-agent systems, where as you increase the number of agents in the system, you see an increase in performance. At the moment, with the best papers, we see performance level out around 1,000 agents. And the reason for that is because there's still problems to solve around coordination and communication and these sorts of things. But hopefully that's what, research groups like here in MIT can work on. And we're doing some work on it too. Okay, so the NAPA platform, what is it? And how do we make it easy for developers to build on top of this new type of decentralized AI platform? Well, we built what it looks like for developers is building MCP servers, as people now know. When we were doing this a year ago, we didn't have MCP servers, so we called them NAPA modules. You can actually see this image from the Anthropic workshop at the AI Engineering Summit just a few months ago. They talk about where they want to move MCP servers to, the vision for it. And you can see that they have 3 different agents, each of them a server and a client. They also have an orchestrator that's a server and a client, and they're, coordinating across the network. And this is a picture from our docs where we have orchestrators running on servers, agents running on servers, tools running on different servers, and they're all cooperating across the network. So we did this about a year ago. We had a POC that used Baby AGI where each agent runs on a different device. So that's like one part of this platform. And the other one is once we have these MCP servers, how do we compose them into workflows and larger multi-agent apps? And the way that you can do that is through the NAPA SDK. So NAPA was the first interoperable agent framework that allows you to, compose agents built with Crew AI and LangChain, with agents written in TypeScript. And because they're all servers, they can all interoperate. Now there's some other agent frameworks that do similar things like MCP agent and fast agent. So they're cool. Then NAPA nodes is the final piece. So NAPA nodes package everything that you need to run agents as servers locally, along with things like local inference and local storage. And we've scaled NAPA nodes to about 50,000 agents running in a single workflow. Okay, so finally, just to finish up, this is the first product that we've built on top of our platform. We launched V1 of our platform around Christmas, and now we've moved much more to go-to-market and product. And Auto MCP is the first product that we've built. It's you can kind of think of it, I don't know if you know Vercel or Heroku or Supabase. They're like backend as a service products that mean that you can just work on the front end of your website and then automatically deploy and host that without worrying about the back end. So Auto MCP is like that, but for agents. So people who took part in the hackathon, for example, you had to, think about the back end and like using the MCP Python library. Wouldn't it be nice if you could just take your existing agent framework and have it automatically create a server for us and then have that hosted on a platform? So you can try this out. Go to the auto-mcp.com website, use your existing agent projects, try out Auto MCP. And also we're on Product Hunt today. Last I checked, we were like number 13 for the day on Product Hunt. So maybe we can get into the top 10 with people here. So if you go to Product Hunt, find Auto MCP an upvote, and that means that, a product from the decentralized AI space will be in the top 10, which is pretty cool. So that's it from me. Thanks, everyone.